A fan has 3 settings: off, low, and high. How many ways are there to set the 3 fans? Many. Good answer.
More than one. At least one.
So if we use the idea of a tree diagram that we had from before, when you go to your first fan, you have 3 options. It could be off, which I'm going to use the letter O. It could be on low, L, or high, H. Good idea. That's fan number 1. Then it doesn't matter what I set fan number 1 at. Fan number 2 also has 3 options. And then fan number 3 has 3 options. Oh my goodness. Good thing we didn't have more than 3 fans. How many ways are there in total?
Oh my goodness.
Oh my.
Man. I don't remember.
Yeah, it turns out
How many are there in total?
I can't even.
Many. You could count them all, right? Right. You could write them all out. This one's, see? Ooh. Right? Right? This is my favorite setting right here. And so on. But if you counted them all, how many would there be? 27. And so it gets a little annoying, especially if someone said, well, what if you had 7 fans? The tree diagram might be a bad choice of doing that. Listing them all would also be a bad choice for 7 fans. We need to come up with a way to figure this out that's quick. Well, we have 3 fans. And so I'm going to introduce to you the fundamental counting principle. The fundamental counting principle says make a space for each decision you have to make. In this case, with 3 fans, you have to make 3 decisions. The setting on fan number 1, the settings on fan number 2, and the settings on fan number 3. So I have 3 decisions I need to make. In those spaces, write down how many choices you have for that decision. So decision number 1 is fan 1. How many choices do I have for that fan? 3. Fan number 2, I have 3 choices. Fan number 3, I have 3 choices. How many choices are there going to be in total? 27. How do we get those 3's to make 27? You multiply. So for each decision, you have a certain number of choices. If you multiply all those choices together, you get 27. Let's go back to our trumpet. Let's go back to our trumpet example. How many decisions did you have to make? 3. Valve 1 had how many choices? 2, 2, 2. Go back to the spinner. You had 2 decisions, the coin and the spinner. How many choices on the coin? Besides it landing on its edge. 2. And the spinner? 2. Total, 4 choices. We listed all 4 of them. This idea is called the fundamental counting principle. Now, the fundamental counting principle in words says if there are n1 different objects in one set and n2 different objects in a second set, the number of ways of choosing one object from each set is n1 times n2. What we did is we said, however many things or decisions you need to make your spaces, and inside each space, write down the number of choices you had for that space. So it doesn't matter how many sets you have or how many decisions you need to make, you can use this over and over and over again. Questions for example 1? Oops, that's example 2. Questions for example 1 are 3, 4, 6, 11, and 12.